Hi, this is the Maker's Quest podcast. I'm Brian Benham.
And I am Greg Porter. And today we're talking a little bit about how to fail your way to success, is kind of how I'm thinking about it,
Yeah.
Brian. And I think anybody who makes anything, and I'll say it this way, who makes anything they're going to sell, right? Or give away things that are other than just Christmas presents that you might give to your family or something like that. They will tell you how many times they had to put something in the bin before they got the thing that they were actually looking to get. And I think we want to take it another step further, maybe, and talk about not just how many times you may have to fail to get it right, but if you're producing a product, then you have to turn that into how can I produce this thing in a way, what process can I use to produce it in a way where I can actually make money? So what's my price point? How long does it take to make and all those kind of fun things. So let's kind of start in this direction. Brian, I think last time we were together, you had just taken delivery of an Avid CNC. I think it's together now, and you're starting to use that machine. I think anybody who's used a CNC will tell you it's not as easy as punching a button. There is no such thing as that. There's a lot of programming involved. There's a lot of thought involved in terms of how are you going to produce the thing. So, what have what have you been seeing in some of your early experience with the Avid?
So there's definitely a long learning curve to get to where I want to be because it's one thing to make a tool path and cut it out. It's another thing to be like, okay, how can I make that repeatable? How fast can I make the spindle feed rates and speed rates go and still get a good product? Because of course I want to maximize my profit. So I want to be able to have that machine just spitting out parts as absolutely fast as I could. And so I have a couple of things to hold up here for failures here. And if you're listening to the audio version, definitely check out our YouTube channel. You'll be able to see what I'm talking about. But I'll try to describe what happened as soon as I could. So this shape, I guess I should also tell you what it is so you
Oh yeah.
understand what it is. So this is the end product. It is basically one of those wine holders. So this goes over the wine bottle, and then your wine glasses hang off either side. So that's what this is. So it's kind of my little yin yang wine bottle holder. So I have my part. It's going, and part of the bottom half is missing because what had happened is I had the feed rate going so fast, and here's the thing that YouTube ruined me because I watched some YouTube videos and read comments of other people, and there are people trolling other CNC guys saying, "Why are you running it so slow? You could have that thing hauling ass, right?" Like, and you watch Izzy Swan, and he's laughing like with this wonderful evil laugh at how fast the CNC is whipping around there, and it's like, well, of course I'm gonna get my CNC to cut parts out that fast, but not so fast because what happened is as it's coming around the curve, these tabs, oh, the camera's backwards here. These tabs right here broke from the pressure as the
Oh
machine went
yeah.
around the curve. So the depth of cut was too deep, and the pressure from the machine, the feed rate was too fast, and broke the part, and the part broke loose. Of course, it got caught up in all the dust collection thing, and then it lost steps, and somehow it thought it was back over here trying to cut, but then the whole thing was flopping around, and so it basically burned a hole in there. So finding the correct feeds and speeds turned out to be more difficult because it's different on different materials. So like
Very
uh,
much.
on the yin and yang thing, I have a cherry and a walnut. So the cherry cut very, very cleanly. The walnut with the same feed and speed left kind of like this fuzz around the edge, even though I set offset on the tool path because the speed was too fast. So it wasn't clearing, or no, the speed was too slow, causing the fuzz. At a fast
Ah,
speed rate, the chips were ejecting faster, and so it gave me a cleaner cut. So, but the cherry was too soft at that high speed rate, and it broke the tabs.
you could actually do a dual tool path, right? Like you could do one tool path for the cherry and one for the walnut. That would be interesting.
Yeah.
So
So, oh, go ahead.
No, go ahead.
Okay, so well, to maximize material, since these guys are mirror images, this walnut's the same shape as this, but I can
Yeah.
cut two out of the same board. So if they're nested together, so I can basically cut two out of the same board, just one's flipped over. So cutting
Yep.
two of these and then do a whole separate tool path for the walnut later on when I cut the walnut parts.
Interesting. Okay. Yeah. Yeah. One of the things that is a really tough thing to grasp with the CNC is sometimes going too slow is a detriment. And feeds and speeds, depth of cut is every bit as important as the speed. And taking a shallow enough depth of cut to allow a fast enough feed rate is critical, because if you're cutting the way somebody described it to me is you don't want dust, you want chips. If you're cutting dust, it means that you're building up heat in your tool, and that number one, it affects tool life and sharpness and all those things. But number two, it can start to burn your product. And coming from a guy who's had two fires on the CNC, uh, which is no fun. That is a bad day when that happens, and it's very it'll drive your anxiety through the roof from there till you die, I think. Um, so so yeah, it that is a really tough thing, because whenever you're taking a big enough cut, it sounds bad. Like it sounds like the machine's maybe getting ready to come apart sometimes.
Yeah. Yeah, I will say the spindle is 5 million times quieter than the router that I had. But
Oh.
yeah, when it's really hauling and making a nice clean cut, throwing chips, it's still wailing a good loud sound. But nothing compared to the router. The router was awful. That was awful to work with in the shop.
That's what I have currently, and at some point I will exchange it. I'm waiting for the auto tool changer feature to become available for my machine, and that's when I'll change over to a
Yeah,
spindle.
absolutely.
Um, well, so from that failure, so talk us through. That's one piece that you made. So let's go through. You've had a couple failures on feeds and speeds, but then as far as work holding and that sort of thing, were you able to just nail that the first shot, or
No,
did you
no.
have to work through some? I saw some tabs on there, right? Like the right
Yeah.
number of tabs can be critical as well.
And putting the tabs in a place that's easy to sand off and clear off, right? So this right here, when I had these nested and they were both cherry and they're nested in the part, this piece would, if I just cut a circle, that tab, I had to put a tab in there, or that piece would blow out and get caught in the dust shroud thingamajigger that's on there. And then I realized, well, why don't I just make a tool path just to hog that out? And then I can just, like a pocket tool
Yeah.
path and just completely drill that out and make it gone, and then cut the rest of the shape out. So, order of operations and unconventional tool paths, I would say like the hole is just a hole, pocket hole, whatever you want to call those tool paths that I just drew on VCarve after the fact, after I drew the whole design. So that way I could just have that specific thing set up there.
Yeah, so you turn that entire hole into dust,
Into
r-
sawdust, yeah.
rather than having a plug come out of there, and that is super smart. It is interesting. Like, I'm sure that, again, as you're looking at price point for that piece, part of that price point is how much do I have to do to this piece after it comes off the machine,
After
right?
the
How much
fact,
handwork
yeah.
is involved?
Yeah, so let me come back to that because I want to say one
Okay.
more thing about work holding. So like work holding, this other piece of failure was not the tabs breaking, it was the hold down that was holding the whole part down came loose because I didn't tighten it down strong enough. And I was on the other side of the shop. So like the machine's still running around trying to cut the shape, but the whole piece is moving around. And so, of course, it cut off the end here, and then it got caught up because it lost steps and it was just going back and forth. And this was jammed up against my little fixture that I had it marking, and so it burned the whole thing. But back to placing tabs or.
Yeah.
Yeah, so placing tabs. So I have another thing that I've been making, so a little cribbage board, and
Uh-huh.
it's got a little pocket on it, and so I got a little finger route in there, and then it comes slides out, right? So you put your cribbage board pieces in there, and then there's a little magnet that holds it in there. So this thing, I originally had it set up to cut this thing. So if you want to cut your inner pieces first before you cut the perimeter, so that way it doesn't move around. Because once you cut the
Right.
perimeter, could move around. But then I had two tabs here and I didn't want to spend the time sanding those two tabs off. So what happened is I stopped using the CNC machine to make this part of the lid and I made a router fixture. And that way I could just clamp a blank in the router fixture with a pattern bit and cut it out faster than it would take me to erase the tab. So the CNC is great, but it's not the end all be all. And then to cut that hole right there, I made another fixture. And of course, I use the CNC to make my fixtures, but another
Yeah.
fixture to set on the drill press with a bull bit to drill
Yep.
those out.
I was just gonna say, there's Mateus Wandel did a great video on he was going to race the CNC machine to I think make a gear or something like that. And he beat the CNC machine, of course, right? Because you have to program the CNC machine or you have to draw it, write the program, bolt the thing down, and then, at the end of the day, you still had to hand sand it. Like when you add it up all the time, it's like, oh man, this CNC takes an awful lot of time. I think one of the things that people lose sight of is yes, on the clock, it may take more time, but when the robot is doing the work, you're able to do something else, whatever
Mhm.
that is. But there are absolutely, when you're doing rectangular shaped objects, you can do them fast. You can you can make them faster and finish them faster by hand than you can make them on the CNC and clean them up by hand. Because generally, if you're on a table saw, you're using a really good rip blade or a really good crosscut blade that's going to leave an edge that has no fuzzies.
Mhm.
And you don't need to clean them up. If you need to clean them up, it's just one swipe with 180 grit or whatever, 320, something like that. And you're ready for finish, where on the CNC, it's almost inevitable. Whatever cut you have, you're going to clean up in some way by hand. Sometimes it's fairly straightforward and simple. It's just a swipe or two, but depending on the type of wood and the direction of cut that you've got, you're cutting top and bottom. So generally, either the top is fuzzy or the bottom is fuzzy. At least that's been my experience, even with compression bits.
Mhm. Yeah, and that last offset step really I found helps with that a
It
lot.
does.
And that took a couple of tries. Is it a thou? Is it two thou? Like how far away do I need to make that to make it worthwhile?
What's your magic number? Is it somewhere around five?
What's a 64th?
64th is uh,
Thing I got to calculate. One divided by
32 divided
64.
by, it's 0.16.
0.16. Yeah, that's 64th is about where
0.016. So
point
16 thousandths.
0.016. Yeah.
Yeah. The easy way to remember that is a 32nd is 32 thousandths
Oh, really?
ish. It's
Ish.
real close. It's real close.
Okay, I gotta
Yeah.
do the math now. Divided by 32. Yeah. 0.031. Yeah, really close.
Yeah. So you could just remember that one and then divide it by two for the
Yeah.
64th. So, but yeah, I found anything under 5 thousandths is a waste of time. You know,
Yeah.
your bit is going to, the spring back on your bit is more than 2 or 3 thousandths in most cases. So you might get a cleaner top edge, but the bottom edge
Yeah,
doesn't
that
change.
makes sense because sorry not to sorry to interrupt you,
Yeah.
but like at the 64th, that bottom edge was a little bit proud, and I thought there's something like I wasn't going all the way down, or there's something wrong with my tool paths, but it's probably just because the bit is leaning out.
Yeah, and it's real prevalent on, and this isn't a dig on Avid or anybody else, but on gantry style CNCs, you've got a lever, right? Like when you add up where your spindle is attached and then where the work is at the very bottom, you've got a lever that's anywhere between 6 inches long and a foot long, right? So
Hmm.
you increase that axial force by that distance, and that's quite a bit, right? When you're talking, milling machines and things like that that have uh, dovetail ways and things of that nature, they don't move very much. When you're talking CNC machines that are on what do you call that? Linear bearings have a little bit of flex in them, a very
Hmm.
little bit. But when you multiply that over, a foot of leverage, it moves. But yeah, 5 thou is the bare minimum if you're stepping over to clean up an edge. You can, I have noticed, and it's a technique we use in machining all the time. It's called a spring pass, where you just repeat the last cut. You don't move, you don't come in, you don't do anything. But what it allows is that takes the spring out of the tool.
The deflection is gone on that final pass.
Yeah. And then it becomes important to experiment with, are you doing a climb or a conventional cut at that point? Because they are different. And in different woods, the same cut produces different results. Um,
And this,
on
and yeah, and also on different angles. Like when you're coming, like if you're doing a conventional cut versus a climb cut on this inside versus the outside.
Yep. Yeah, very much so. And I've learned with plywood anyway, I reverse the last cut. So I step in somewhere between 5 and 10 thousandths, and then I reverse the last cut with a compression bit, and magically it cleans everything
Hmm.
up. If you do it any other way, it doesn't work.
All right.
And uh, at least that's been my experience. And I'm getting well, here you go. Here's one right off the machine. Like really, really
That's pretty
nice
clean.
edges
Yeah. I'm gonna have
there.
to try your half thou because I at 64 I was satisfied, but it wasn't perfect. And that one's pretty raggy on that
That's
bottom edge.
that's non-reversed, right? You can see
Uh-huh.
this didn't cut all the way through the
True.
bottom
Yeah.
everywhere, but this is the type of artifacting that you get. I grabbed another piece to show. Where's it at? The other one is you get chip out. This is
Hmm.
the top surface. You get chip out if you don't do it correctly. So it's definitely, I say all that, Brian. We were talking about failing your way to success, right? Um, I can't tell you how many oddball shapes. The other piece of this whole puzzle is you have a top laminated sheet, right? The grain direction goes one way, and if your part is oriented this way, it produces a different result as well. So you're always going to have to deal with some boogery ends or whatever, because you can't have a part that's all four sides are oriented the correct way. So you pick your short sides to orient against the grain, and that does change things as well, because the feed and speed that you have with the grain that makes it look good may not be the right feed and speed at the ends of the grain,
Hmm.
which,
Oh, yeah. I have a perfect example of that now that you said that. So on my little cribbage board example, this pocket, so that thing slides into this little keyway here. So
yep,
this was a multi-tool thing. I used a 1/4 inch end mill to carve this out and this little step right here. And then I did a tool change with a key bit to go around this. And this I had the first time I had this thing like hauling at 200 inches a minute or whatever, just zip it. I was like, oh yeah, that's great. It's going to take no time to cut those. But then when I pulled the part out, going across the end grain was just chipped up, even though this was nice and clean. So then I had to slow
yeah.
way down that thing, and then I was like, dissatisfied with the amount of time it was taken, but that's what it took to get that clean cut across that end grain.
And you can, depending on what software you're using and all those fun things, you can divide that path, right? Like you can take one speed on the, but yeah, you can break that contour path up and say, take it this speed on the long grain and take it this speed on the end grain. And but that takes an awful lot of work to do, and you have to really want to,
To
make your
set all that up. So and that
yeah,
wouldn't be something I could do. Well, I guess I could do like this line in as a tool path, and this is a tool path, and
yeah,
this is a tool. But since it's a key bit, I can't plunge in here. I have to start up
right.
here. So
Yes.
that's going to
It
be, I'd have to
it
set
takes
my,
a lot of planning. And
yeah,
you you can edit it by hand as well, right? You can change the speed anywhere in the code. Um, it just takes some doing.
yeah.
But
One
yeah,
thing I
you
don't like about what I've got going on with some of the tool paths is it will do a thing even though it's on the same path, like this last pass, it will retract the bit and go back to the start and then do the final path instead of just continuing on with the final path. I feel like that's like a waste of 5 seconds, but still 5 seconds adds up over, 1,000 parts.
it does. And that was one of the things I wanted to mention, as you as you make parts, right? And you start to get good parts. I feel like it's important to start out slowly and to work your way up into an optimized program. But if you're making 100 of a given part, the optimization is absolutely mandatory. You cannot stop. Once you get one good part, you really do have to look at, how do I take 30 seconds or 3 minutes or 5 minutes out of this part cycle? Because if you don't, then you get to pay for that, right?
Right.
And you pay for it either in the fact that you're going to be waiting on the machine, so you're sitting there staring at the machine, or uh, the machine is just going to be cycling way longer than you want it to. And that optimization is something that comes, I feel like, with experience. But anybody who sits and watches a program, I'll kind of give you a little bit of, I'm not going to call it my secret for success. That's not it at all. What I do is, as I'm doing prototypes, which I think is where we spend an awful lot of time, right? That's where we shake out all the bugs. We make all our mistakes. Parts go flying across the room. Things don't fit together well. Um, as you're making those prototypes, I'm constantly taking notes, right? If you don't write it down, you'll forget it because there's too many things. I'm constantly taking notes about, oh yeah, when it was drilling this hole, I had it on a peck drill cycle, and the peck drill wasn't going nearly far enough, or the drill was coming down and then it was going into its slower speed 2 inches above the workpiece, and I could make that an eighth of an inch instead of 2 inches, right? You can wrap it down to the surface and then go in. And I constantly take those notes. When I get it to a point where I'm positive I'm going to have a good part, I name I name that program RTM, which is ready to manufacture. So I know once I have an RTM, I can hit the button and get a good part. Once I get to an RTM, I'm constantly looking for, how do I optimize this, right? That's when my optimization really starts. And then I go through RTM 2, RTM 3, 4, and I never stop making ready to manufacture files. I'm always looking for a way to optimize. And I think on some of my parts, I'm up to RTM like 30 something. So I've had it producing good parts, and then I've had 30 versions plus of optimization for those parts. And every time you do it, you either save a little time, you have a little less wear on your tool. The the other thing is, I think any of us that are making CNC parts, you have failure parts. You will scrap parts. Even if you've made 1,000 parts, you will scrap parts somewhere along the line. But you try and spread out that failure further and further and further. So every time you do have a failed part, you look at why it failed, and then you try and fix that failure so that it doesn't, so you're not wasting money, right? Wait,
Right.
money and time.
On the failure parts thing, yeah, each piece of wood is different. So you might cut that part 1,000 times, and then you throw another board in there, and all of a sudden that board just splinters up all hell, even though it's the same tool path. And I've had a few of those. And then you have to ask yourself, okay, so is it worth the time to sand that part to fix it, or do I just throw it away and keep going? Because going back and fixing things, like that's kind of like when I'm building a custom piece and it's a one-off piece, And I spent a whole bunch of time making this one part, and a piece chips off, and like, okay, well, I'm going to glue that piece back down or glue it back together and save that. That's worth saving because I spent all that time doing it. But on the CNC machine, it just spitting out parts. It's oftentimes better just to throw that part away and throw a new
I've
piece
got
on.
I've got a pile like these two pieces are for the uh, same product that I make, and I have a pile of probably around 100 parts that have come out of that program. So that program makes four finished products out of 3/4 sheets of plywood. That so my machine is a quarter sheet at a time. I run 3/4 sheets. I get four finished pieces, and each piece has what is it? One, two, three, four, five, six, seven, eight, nine, 14 pieces to it. I think no, 14 plus four, 18 pieces, 18 parts. So um, when I get a bad part, I don't, I just look at it and go, okay, I'll put that part over here. The next batch I'll steal apart, and eventually, you sort of put all your good pieces together and it
Hmm.
makes up whatever. But that pile of quote unquote bad parts are all what I call rework parts. They require some handwork, maybe I can bevel the edges and save the part, do something like that. So whenever I have quote unquote downtime in the shop, I've got my whole pile of reworks and I just start into them, whether that's on the router table cleaning stuff up or with the hand sander or something like that. So if I have an extra hour, I just clean up pieces, and you do enough of that and eventually I get, finished products that I can put out the door that are in good shape. Uh, but that's how I approach it. If you try and stop in the middle of production and fix that one piece, you'll never get done.
Yeah, yeah. I have a similar pile, but I never ever seem to get to that pile unless someone orders one and I realize that my inventory is off and I don't have one, then I'll go to that pile and make one.
I,
That's
I
usually
do
how
that
that
too.
works.
Every once in a while, you have a piece there and it saves the day.
Yeah.
5 minutes worth of rework will save your day, and it never fails. That particular product, uh, 10, 20, 28. There's 28 screws that go into it, and if one of those screws accidentally cracks apart, or I'm sure you've screwed enough into plywood. Every once in a while, you snap a screw that's going in, and
Mm.
that is a bad day, right?
White
Like,
oak is my nemesis.
yeah, it's that.
Hmm.
And you're trying to drill pilot holes that are the appropriate size, not too big, not too small, because if they're too big, they strip out. If they're too small, screws break. And every once in a while you just get a bad screw and it's going to get you. And when you break a screw off in something, then you got to save it, right? So there's some part that gets drilled out that is scrap now. And that, like I said, when you're drilling, call it 30 screws into pieces and you're making them a dozen at a time, you're bound to have something bad happen. So having those extra pieces is pretty helpful. I did want to pivot just a little bit. So on the prototype side of things, right? We can prototype with the CNC. We can prototype by hand. We can also prototype with a 3D printer. I know you're much more skilled with the 3D printer than I am.
I wouldn't say that. I just didn't show you all the cuss words to make
Well,
some of those parts.
I think the one thing that I would say about 3D printers that I've learned is that it takes a while to get good parts out of a 3D printer. It's the
Yeah,
same way, right? Like you just don't hit the button and get good parts.
right.
And I was going to show uh, some of the things I've been working on, which have been kind of fun in terms of how many shots it takes to get what you're looking for. So I'm working on um, a geared what do I want to call it, assembly. There we go. That can raise and lower a platform on some Acme thread. And so I've got this, they call it like timing belt. So this is a G2, I think is what they
Hmm.
call this timing
Okay.
belt. And you would think these things are spaced an even amount of whatever apart, an even measurement apart, piece of cake, right? Like I can model that into something round and it'll fit.
Yeah.
And Surprise, surprise, that is not the case. And you look out on the internet for, other people who have modeled, little timing gears like this.
Hmm.
And my dog has gotten a hold of a few of these. And I have, here you go, there's more than this, but it took this many iterations, however many that is. There's probably a dozen in my hands right now,
Hmm.
just to get the timing belt to fit. Not not to get the apparatus to work, but just to get the timing belt to work and fit and not slip as you're kind of pulling on it. And then I've got threads, and I'm trying to get the light right. I've got threads down the center of this, Acme threads down the center of this, and same, right? Like you
Right.
model threads in Fusion or some other program, and then you get to real life, and it's like, well, not exactly. And so you adjust and you make things looser or tighter, and then I've got kind of, it looks like a window crank from a car if you remember
Hmm.
when cars used to not have power
Yeah.
windows. And how many iterations of this does it take before you're no longer breaking the handle off or doing any of those things? I think I just snapped that handle, as a matter of fact. Yeah, I did.
All
uh,
right.
but this is an older version anyway. But we go through those things, and I guess the kind of end all be all message is, if you think you're going to get it on the first time and not fail, you're wrong. And there's a whole saying out there, fail fast, right? And
Right.
that doesn't mean fail on purpose. It means get it all out, right? Like just start making the thing and figure out where all the failure points are and do it as quickly as you can, because that's how you get to the good parts. With the 3D printer, what's been great is I think that technology has come along a long way
Hmm.
in the past, I'll say 10 years. Uh-oh, my dog's jumped up here now.
She wants those parts to chew on.
I know she does. She's dying. I'm sorry, sweetie. What the hell was I saying? Oh, technology and 3D printers has really come along. In that, I bought it's called I'm looking at it now. I think it's called Kidi Tech, QIDI, Kidi Tech, something like that. And it's one of those enclosed printers. And I don't have to glue the base of it. I don't have to worry about parts warping off of the platen and ruining things. Like you hit the button and the parts come out pretty much like you programmed them to, which is so far different than when I started 3D printing years ago. And it really does allow you to very, very quickly iterate, make your mistakes and move on. And I don't know what your experience has been on 3D printers and making things. She is just not going to yield. What's your experience has been, Brian, on doing similar things on 3D printers? I know
Yeah.
you've done a lot of work with them.
So as far as like failing fast, right? So I wanted to print 3D print a threads that would thread onto an actual nut, right?
Yep.
So if you know anything about 3D printing, you know that it takes forever. So when I first modeled this, I only modeled whatever the height of this nut was, so I could make sure it followed that it would spin on. So I was like, okay, so I only printed a half an inch, so that only took 30 minutes versus 3 hours for the whole thing. And then once I got that, then I was like, okay, then it took 3 or 4 tries to make sure this would spin on there to do all that. And then once I got it fitting right, then I printed the whole thing,
Yeah.
finished the drawing. So I only drew like what is the most critical part that I need to make sure fits together. And I'll do that a lot on a lot of things. Like I have some adapters that I've printed for dust collection to fit different tools. So I might print just like a 1/4 inch of that thing, like a washer, just to make sure it fits on there before I print the 3 inch long piece that I actually need. So that way I can quickly adjust, like, okay, that one's too tight. Let me open it up a couple thou. Right. And then even then, it's not always a perfect way to go because you print this 3 inch long thing. That's a lot of mass, right? So
Yeah.
then that cools and it distorts a little bit sometimes. So,
Yeah. And I know that was the big thing for me, kind of jumping back into 3D printing. I abandoned it because I was so frustrated with I'll call it the tolerance of things, right? Like you could have an inch of good material that was had a good tolerance to it, and then the next inch was awful. Maybe it was offset or warped or a little, you know, cockeyed or something. I don't know. Um, and I feel like now this thing has got, I don't know, some kind of weird anti-vibration technology. So it counteracts whatever weird vibrations are in the machine. And so far, it's worked flawlessly. I've been so impressed with it, and I think there are it's so much more accessible that technology is right now than it was even just a couple years ago. And I think like Bamboo Labs and a couple other
Hmm.
people pioneered that, and everybody else is just sort of caught up.
Yeah, and you wouldn't think that vibration of the machine would throw things off, but it does. And a weird thing, like when I first set up my 3D printer, I just set it up on a card table in the guest
Yep.
room because no one ever uses that room unless I have guests, right? And so it just, and that card table has all kinds of wiggle in it. And I was always like, why are people getting better prints than me? I don't understand it. But then my mom came to visit and I took the 3D printer downstairs and I just put it on like a solid side table that has no movement at it at all. And I printed some things off of it while I was on that table, and it was like night and day difference not having all that movement.
Yeah. Yeah. Um, I did want to kind of uh, venture into another area
But
talking about the.
before we
Oh,
do
go ahead.
that, I want to pick up two little tips that I thought about while you were
Yeah.
talking in regards to stripping the screws or breaking the screws off. I have been buying stainless steel screws. Like Lowe's has a
Mhm.
stainless steel screw section, and those are much stronger, and the heads don't twist off like your standard screw. So I mean, they're a little bit more expensive, but like it's a $2 bag of screws instead of $1.75 bag of screws. So like it's totally worth not having to try to spend an hour getting a broken screw off. So that was just one little thing that I thought of. Like that's just like a recent discovery of mine because I did an outdoor project and I didn't break any screws and I was like I just gonna buy stainless steel from now on. And then
Yeah.
the other thing is as far as like scrapping parts and things and prototyping, I kind of have developed this dozen at a time rule. So like I'll make 12 of these at a time. And so that way, if I'm probably going to get 10. So I'm going to price it out at 10 versus 12, but I'm going to make 12 so that way I can throw away two if something goes wrong. And then also for ADHD, spicy brain individuals such as myself, if you have to make 100 of these for an order, to sit down and glue 100 of these together is the most painful thing ever when you have a spicy brain. So if you make a dozen of these and then you make a dozen of something else and then you go back and make a dozen of these, it's way easier on your brain. And then
Yes.
the final point of making a dozen at a time is what you touched on of your RTM 30, RTM 31. Um, you make 10 of them, you're going to notice during that 10 where you can improve things. So then you can improve on the next dozen.
I I think we can coin a new term here today, Brian. The maker's dozen.
The maker's dozen. Yes. Make a dozen. You're going to be able to work out all kinds of details on your first dozen. And then your next dozen, you'll be able to dial it in even further. Because if you were to cut out 100 of these, uh, during that time, you're going to notice something, but you're already in the process of cutting 100 of them out, or you've already cut 100 out before you realize that, oh, I should have just bored all these out instead of cutting all that tabs. If I had 100, which in this case, 200 tabs, 200 tabs to cut, if I would have noticed that after the first dozen, then then I wouldn't have wasted all that time on the other 80 of those.
Isla Moose is being incredibly needy tonight, aren't you, girl? I'm so sorry.
Oh,
You
she's
want
gonna
to
lick the
speak her the
microphone.
she has never been like this. She has been so needy. I'm sorry.
She's very jealous that you're not paying enough attention to her.
She is, and Anyway, I swear to the people out there in podcast land that this dog lives better than most human beings do. She's just feeling super needy tonight. I'm gonna try and put her back down on the floor again. I'm sorry, sweetie.
Okay, yeah, the maker's dozen, right? Yeah,
Well,
that's a
and
good coin because right, if you don't want to cut out, if you realize halfway through that you should have drilled that instead of cut it out, but you've already committed to that
yeah,
thing, right? It saves yourself so much time.
and the maker's dozen yields 10 good parts.
10 good parts, yeah.
If you're lucky, you get two bonus ones.
Two
Those that
bonus
maybe,
ones.
if
That's your
I
profit
like
margin.
I like the way you say that in terms of, uh, you're looking at your pricing with 10 parts, even though you're making a dozen of them. And that's where you start to really make your margin is if you can get 12 good parts, right? If you can make money on 10, you're good, right? Like you're
Right.
solid, you're going to get there. And if you wind up getting lucky and make 12 good parts, which after a few cycles, you'll get 12
Hmm.
good parts every time, and she's back.
Right.
Uh,
Then it won't be as painful as if you only get eight one time because you know you got two extra from the last run, and so it kind of washes out.
yeah,
We
girl.
we might need to get her some headphones and
I
a chair
know.
so she can
Do you
join
want
us.
do you want to be part of the podcast? Thinking about different things. One of the things that I think goes hand in hand, we've talked a little bit about it, is different material and what it takes to really um, understand. It can be really frustrating. Let's start there. It can be really frustrating when you start working with a new material to work through the kinks. Um, and one of the things that I've developed, and of course I don't have any examples of it here, is a grid of square pieces. And but if you have, let's just say I want to make some stuff out of birch plywood and I've never used birch plywood before. Just do yourself a favor and make a grid of 2 inch by 2 inch squares and work on cutting out those 2 inch by 2 inch squares with different feeds and speeds, different depths of cut. If you're going to try a conventional versus climb milling, if you're going to try, like we discussed earlier, that 5 thou or 10 thou step in at the end, that little set of, call it 10 by 10, 2 inch squares, that is enough experimentation to give you all the answers that you need to make those parts well the first time. Believe me, if you start out with big parts like this and you're doing quarter sheets of plywood at a time and screwing up quarter sheets of plywood, the cost of that mistake becomes very expensive after about 5 or 6 of those. And it's not just, sheet of birch plywood is $100 now, right? Three-quarter
Hmm.
inch birch plywood is about $100. The $100 is one piece of it, but what's your time worth? How many hours did it take you to waste through that sheet? And I say all this not from the all-knowing God position here, but from a guy who's done it, right? I've had that failure so many times. It's like, why don't you come up with something smaller and easier to screw up and throw in the bin? Uh, and the other one is the other fun piece of this is these intersect, right?
Hmm.
So there's a tolerance there for that lap joint, and I don't know. I probably made up oh, 30 different samples of interlock, just that don't joint. It's like a 2 inch piece, but 2 inch by 2 inch piece with a lap joint in it. And part of it is how much clearance do you need for them to slip together? Okay, great. But then how much clearance do you need for the centers to meet right at the center and be flush on both sides without, having to hand sand off? If you've ever tried to hand sand off 5 thousandths of an inch along the edge of a piece of plywood, it's not the easiest thing in the world to be good at because you can't use a hand plane to do it. The hand plane would be my number one tool, but you can't. Plywood doesn't work that way, especially the thin veneers that they put on birch plywood right now don't work that way. If it was the old birch plywood, it would work just fine.
Yeah, and then you also not just the loss of your time, but there's something that people don't talk about is the bruise to your ego. Like
Oh
there's
yeah.
some days in the shop that I'm like, I, what am I doing? How do I even call myself a professional here? Because this is a freaking disaster. Like it just happens. Like, and those are the days that I just don't tell anybody what happened in the shop that day.
We I think we all suffer at some point from imposter syndrome.
Yeah.
Like, I know I'm telling everybody I can do these things, but can I really? And then there are other days when you step back and you're like, that is amazing.
Yeah.
Did I really do that? And that's not a ego braggy thing. Like it is kind of amazing how, several years of skill building, how good you get at certain things where it's almost unconscious. And, you're in the flow in a shop and all of a sudden, you've got this perfectly fitting fill in the blank. And it's kind of amazing to sit back and like, yeah, I did that.
Yeah. Yeah, a perfect example of that is like when I first started cutting mortise and tenon. It's like, all right, so how am I going to cut a mortise and tenon? Am I going to use a chisel and cut it by hand? Am I going to get a mortiser for the drill press, which I did? And I was like, this is a terrible way of cutting mortise and tenons, and it takes forever. And then I'm like, all right, well, then let's do the router method where I set up a whole fence system to cut routers. And I'm like, yeah, this is way better. So now, and then even laying it all out takes a long time because you have to think like, well, how far do I want it to do? But then after you've done 1,000 of them, you've built a procedure for yourself, whether you want to call it a procedure or even if it's subconsciously doing it, you just like, okay, I got to do mortise and tenons down. And then you just do your procedure and you knock it out. You don't have to stop and think about it. And you just move so much faster through your work.
Yeah, I'm always amazed when I see I'll call it cabinet builders, but that's probably not the right word. But guys who produce a lot of cases, whether that's furniture cases or cabinetry, how quickly they get through the rough stage of what they're doing. And when I say that, everything's cut to maybe not cut to final length, but cut to rough length and marked out and ready for all their tenon joinery and those types of things. The guys who've done it, and I think Brian, you're probably one of them, although I've never sat and watched you in your shop. It's second nature how quickly they put that stuff together. If it's me, that's not my area of expertise by any stretch. Fine furniture is not what I do. It would take me forever to write down the cut list and this piece gets that and make sure that this edge is up so that it matches around the corner for that thing and measure and remeasure, mark and remark. It would take me a month of Sundays to get through that stuff.
Yeah, the cut list is my nemesis. I don't use a cut list in my shop any longer at all because you'll have way more success if you like, all right, I need to cut a rail to fit in here. So I'm just going to hold the piece up there with a knife and knife that line in there. It doesn't matter what the cut list says because a cumulative error, it could be your rails could have been a 64th inch bigger because you set the fence a little bit fat on the table saw, and that's going to not match the cut list now. So now when I draw plans for the Wood Whisperer and I have to do a cut list, I'm just like, oh, I hate the cut list. And then people like proofread the cut list. Hey, there's a typo in the cut list. Like, who cares? Like, don't use the cut list. The cut list is just to go buy your material.
Yeah.
After that, throw that cut list away. That's
Yeah.
sorry, that's my rant. I hate cut lists. We should normalize not using cut lists. They're
We
just
can
there to
normalize.
figure out your pricing and to buy material.
You and I can agree to that. I don't ever use a cut list either, but I'm not building anything for let me say that differently. I'm building jigs and fixtures that are very repetitive.
Yeah.
There's no cut list about it.
All right.
I know what they need to be.
Yeah. Yeah. So on our trip here, we haven't talked about recovering parts. Well, we talked a little bit about recovering parts, router things, but like, what if it's too far gone and it's a big piece of material? What do you do then?
Oh gosh. It I think for me it all depends on the cost of that material, right? Is it is saving that piece of material going to get me more dollar value than throwing it in the trash, right? Like what amount of time is it going to take? And I'll go back to I I do a lot with sheet goods. I do a little with hardwoods. Most of the hardwood stuff that I do is very hand oriented, so the machine is not going to screw it up. It's going to be me. Um, but on the sheet good thing, like I know every every quarter sheet of MDF that I throw on the machine is $20.
Mm.
What's my time worth? right? What's $20 worth of my time? Is that 15 minutes? Is that half an hour? Is that an hour? I can tell you it's closer to 15 minutes than it is to an hour.
Mhm.
And so if I screw up an entire sheet and I go, well, it's going to take me an hour to recover all the pieces and parts out of there, it goes right in the bin. If I look at it and I go, you know what? I could, my machine got three-quarters of the way through that. I could throw it on the bandsaw real quick, rough everything out, put it on, a pattern bit on the router table and be able to knock those pieces out in 5 or 10 minutes. Yeah. Then it goes on the rework pile and I get to it when I get to it.
Yeah.
If we flip this over now on the guitar side of things, right? I deal with some exotic woods on the guitar side of things that uh, are $100 a board foot range. Some of them are a little more, some of them are a little less. And when one of those pieces goes astray, there's a lot more that I will put into saving that piece.
Yeah.
And and even at that, I'll give a recent example. I'm working on a couple acoustic guitars that I'm making out of some Ovang call. Ovang call is not an exceptionally expensive wood, but you get it in 4/4, 8/4 boards, and then you have to mill it into backs and sides, which are, for lack of a better measurement, a 16th of an inch thick, between a 16th and an eighth thick. So you run it through the bandsaw, you run it through the drum sander or the planer, and by the time you have a back and side set, you've got an hour, maybe hour and a half into those four pieces of wood. So the wood itself, $20. The time invested now, you've got $150 into that set. If I put it in a side bender or do something like that, and there's a crack or there's a defect in that piece of wood or something else, I am going to spend as much time saving it as I've got into it because I don't want to have to go back through and remill all the lumber to make those pieces again. The other thing is guitars are symmetrical, right? There's a top and a bottom half, but they're all book matched. Generally, they're all book matched. So if you ruin one piece, you ruin the other piece. So so one bad piece goes in the trash, both pieces go in
Both
the
pieces go in
trash,
the trash.
or they become, experimental pieces for something else later down the road. But you really have to pay attention that way. So yes, I will go after those pieces. And now, uh, flip up the heat on the burner here. I do have a back and side set that I paid well over $1,000 for. And what happens if something goes wrong there? I will spend a small fortune
To fix that. Yeah.
diving into the water to save that guy from
Okay.
drowning. There's no doubt
Yeah.
about it. Yeah.
Yeah. So yeah, that's a perfect segue into something that I'm kind of proud of. I'm proud of this mistake. This is so all right. So we've all woodworkers have made cutting boards probably. We've all tried to sell them, right? And this show that I'm doing is more craft than art. So that's why I'm making cribbage boards and things for this particular
Mhm.
show. So of course I have to make some cutting boards, right? So these cutting boards are about 12 by 16 in grain cutting board. If you've ever made one before, sanding in grain and sanding all that glue squeeze out is a pain in the ass. So I put it on the CNC machine and did a tool path to surface the fronts and flip it over, surface it again so I can send it through the drum sander, save myself hours and hours of sanding. But to get to the blank side took forever. And then I had a catastrophe of lack of hold down power. And one of them got all wonky in the machine and it effed it all up. And I was like, dang, that's a lot of work that just went down the toilet. So what I did to save it, and this is why I'm kind of happy it happened because I probably would have never thought of this, but I cut it up into smaller pieces to make, and then resawed it on the bandsaw to
Little
make little
trivets.
trivets. Yeah.
Yep.
And then coasters. So because of that screw up, um, I have two new product lines now that I wouldn't have had before. And then here's the thing. To make these, like if you were to make a half-inch thick one of these, that's a huge pain in the ass to do.
Oh yeah.
But these ones go pretty fast because they're pretty thick. right? And so basically, I make these, and then before going through all the sanding, resaw it and cut it into these. So, so let's say I'm selling this for $100 and selling this for $25. Well, I can get 400 of the $400 worth of these out of this thing. So these small things turned out to be more profitable than the actual product that I was trying to make. So it was like this great little happy accident.
It is kind of crazy how that works. And to your point, Brian, sometimes saving something means turning your back on the thing you really wanted and making something smaller
Yeah.
that comes out of the same chunk. And I see people in the guitar world. There's guitars which are normal size, and then there's ukuleles which are half to a quarter size, and a lot of rotten guitar projects turn into ukuleles.
Yeah, that's a thing that I realized early on, like okay, I'm making a tabletop. Oh, I screwed up the tabletop. Okay, well now I can cut that tabletop up into rails and styles and make a cabinet. Oh, I screwed that up. Oh, well, I can put that on the lathe and turn that into little pen blanks and make little pens. Well, I screwed that up. Well, that's all right. I have artisanal sawdust.
That's right. Artisanal sawdust. Uh, I can remember. I'll name drop for a half a second. Jimmy DeResta sent me something one time, and inside he had folded up a piece of paper and wrote some things on it and stuck a bunch of sawdust in the paper. And on the bottom of it he says "Real New York shop sawdust" or something like that. I was like, thanks for sending me your trash, Jimmy. It cracked me up because I could just see him doing it and laughing as he was putting it in the envelope. But
Ah,
uh,
that's great. I wonder if I could sell like little envelopes of sawdust. Sawdust,
God,
50
I think you,
cents.
I think you totally could. Yep. Well, if it were aromatic cedar, you could
Oh yeah,
absolutely
absolutely.
do that. I'll send you. No, that wouldn't work. I was going to say I've got a bunch of Spanish cedar that I've been cutting up for guitar necks here lately, and interestingly enough, when you cut it, it smells awesome. If you breathe it in, it tastes incredibly bitter.
Someone
So,
told me that that was extremely, extremely poisonous.
is it
Spanish
Spanish cedar?
cedar. Yeah, I
Yeah.
don't know if it is or not. I've only built one thing with Spanish cedar, a humidor out of it, but
Well, I can tell you when I work with Spanish cedar, I do wear a respirator.
respirator, yeah.
Most of the exotic woods, and Spanish cedar isn't really an exotic wood, but most of the exotics that I do, I know you develop. It's not tolerance; it's the opposite way around. The more exposure you become, um, what's the right word? Sensitized
Hmm.
to a lot of those hardwoods, and rosewood is one of them that I hear a lot of people struggle with. Cocobola, which is a rosewood. Um, a lot of those, the more you breathe them in over time, the more they'll irritate you. So, I I know that I want to build guitars for a long time, and the woods that we build guitars with are
Hmm.
all that nature. So I keep a pretty close eye on it. But every once in a while, I'll be sweeping something up, and all of a sudden, you'll just get like this little bit of a taste of Spanish cedar, and it is extremely bitter. And yeah, that's probably it, right? The human body will tell you if something's poisonous, it tastes
Hmm.
bad, right? And if it
Right.
tastes bad, it's poisonous. So, um, but yes, you could sell little bags of Spanish cedar because they do smell incredibly good, which is awesome to make guitars out of because it makes your guitar smell good.
Yeah.
Well, so Brian, we've been talking an awful lot about failing and kind of the initial stages of how we get successful products out of machines, and to some extent by hand. And I think eventually, when you're looking at a business model, then the question becomes, how many of these can I make? How many of them can I sell over time? And that's how you increase your revenue and make these things into real money makers and retire and buy yachts and things like that. But uh, I guess my question for you is, you've now got this Avid CNC that we started talking about. When we started the program, it's the same one I have, 2 foot by 4 foot. I think yours is going to have a fourth axis on it as well that'll be able to do some things. But as you look in your crystal ball, is that you do a lot of furniture that's built by hand, but I'm guessing this Avid is going to help you in making the furniture that you do, as well as some of the other products that you make. Where do you see, if you're looking in your crystal ball 5 years from now, where do you see, is that Avid still going to be kind of the heart of your CNC production, or is it going to be a piece of it and you're going to have other things?
So a piece of it to have other things. So I didn't buy it necessarily to make furniture, although I have plans to make furniture because I got the vertical work holding
Yes.
uh, jig to go with it, and that way I can do floating tenons and all that kind of stuff. But that's not really why I bought it. That's just kind of expanding my options as a furniture maker to have an additional way of doing things or a more accurate way of doing things. What I really bought it was, um, how do I explain it? So I guess a best way to explain it is how I learned it. A few years ago, or a few vacations ago, I was in Zion
Yeah.
National Park. There's this little town called Springdale that you can stay in, a little touristy town just outside of the park. And there was this photographer and he had a gallery right on the main street there. And I was thinking to myself that like, how does this guy selling enough photography to pay the rent and um keep himself fed and his own mortgage and all of the things and be able to have the gallery open while he's manning it and still go take pictures. And so I just kind of casually mentioned to him that, hey, this is what I do. I would love to have a gallery, but I can't figure out how to afford it. And what he told me was to make your art accessible to everyone. And that's like price point. And so what he has in his gallery is like he has puzzles of his photography. He has keychains with his
Oh,
photography on it. He has bookmarks with the photography on it. And then of course he has on the gallery walls all over the place $5,000 huge glass prints that he's done of his photography for those that can afford that and have the wall space to put it. But he said those are the ones that really make him the money. But he doesn't sell one of those every single day, right? But he sells a keychain and he sells a puzzle every single day too, because there's all kinds of tourist traffic coming in and he's like that's what keeps the rent here paid, and that's what allows me to hire an employee to go take photos. Is that I'm not getting rich on that. I'm not making like a lot of money on that, but it's making the business stable. And that's one of the things that really stuck with me because as a furniture maker, when you're doing custom one-off things, you have to find that custom customer every single time. And you're starting from
yeah.
scratch every single time. So it's really hard to keep that cash flow going. So to be able to sell a cribbage board at a $25 price point at a craft show or whoever else I can find to sell this to at a reasonable price point just to generate cash flow is kind of my thought um, to grow the business. And then the idea, so let's say I figure out with one machine how to make this at $25 price point. What if I get a second machine and then I'm making both of these at the same exact time? Now I've just doubled my price. And then if I hire somebody that is standing there manning both sides, feeding the machine, and then while the machines are running, he's sanding this piece or sanding this piece because there's a sanding station between the machines. So now he's sanding and babysitting the machines, and there's two of them running at the same time. So now I'm making money, right?
Yep.
So that's
Yep.
that's the long-term goal, but I have to develop the product, find places to sell it, figure out the right price point to sell it because if I'm like, oh, this is $100, no one would probably buy it, but at $25 at a craft show, someone will buy it or $30 in a gift shop somewhere, someone would buy it if I could figure out how to make it for 15. And that's when you get two machines going. I could probably get that price point to 15
Yeah.
for the
Yeah.
because the gift shop would have to, would want to at least, most businesses like to double their money, right?
Yep. Yep.
So
That's
that's my
exactly right.
long-term goal. And then once I got that going, I got a guy to help me lift the table and get it stuck in the elevator at Red Rocks, right?
Yeah. Yeah, for sure. Well, I I constantly am talking about if I can go out in my shop and have at least one robot working while I'm working, that doubles the output, right? Like,
Yeah, absolutely.
and if I can have two robots working while I'm working, that's even better. And if I can have all three going, my day is just fantastic.
Hmm.
It's pretty rare when I have all three robots going. And when I talk about that, I have a laser cutter, I have the Avid CNC, and then I've got a milling machine, a Tormach milling machine that I use. And if all three of them are going, which does happen, it takes my full attention to keep all of them fed and to keep tools from breaking and things from
Hmm.
going awry. Like you have to be really dialed in when that's happening. But but it does happen. And when that happens, it's like, man, I feel like I'm really generating some revenue on
Yeah.
those days.
Yeah, it feels good. So like when I was making this wine thing, this was a few minutes tool path, but I cut them out in pairs and I had them stacked on the machine so it could just go zzz, 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 so it would run for 20 minutes. So while that was running, I was just building my normal commissions like I always do. And then at the end of the day, before I left the shop, I glued the two halves together. And then in the morning, I sanded and finished, and then started the cribbage boards. And while I was working, finished drying, cribbage boards are cutting on the machine, and then I'm building my commission furniture while the machine's making money. So I was
Yeah.
like, I'm feeling good. Like this was a good decision to buy this machine. Now I need two of them and a guy.
Yeah. And it's interesting too to look at, like, once you have a CNC router or something like that in your shop, and you're able to, again, you've gotten to the RTM stage, right? Like you hit the button and parts come out the other end,
Hmm.
and for the most part they're pretty darn good. Then you back up and you go, how in the world did I ever make money when I didn't have this employee over here that I don't have to feed and pay for, right? Like I paid
Hmm.
one time. I wrote Avid a check. I write checks for, drill bits and, or sorry, machining bits,
Hmm.
and mills, things like that. But those checks are relatively small compared to the price of the machine.
Right.
And I don't know what I spend in tooling a month, a couple $100 max, probably. And for a couple $100 a month, how many dollars worth of products are pooping out at the other end of that machine? And there's no way you could do it by yourself. So anyway, and then when you add a second machine, you start to ask that question even more. And at some point, I feel like I'm going to have a robotic arm or two or three feeding parts into machines and hitting the go button. Uh, and at that point, I'll be like, how did I ever
Right.
survive with just human labor? So,
Right. Yeah, with the CNC machines getting cheaper, like desktop machines, even though the desktop machines aren't great, but from my experience of having one, but it's still manufactured parts. This was originally cut on my desktop machine, and this is the one that really burned up the palm router that
oh
was
yeah.
in that machine because it was just like constantly feeding it all day long, and it just got hot and smoky and a lot of things. I forgot where I was going with this, but yeah,
Well,
where
the
was I going with
desktop is a
that?
place to start, and
Right.
it's kicking out part, like they pay for themselves.
Hmm.
There's no doubt
Yeah.
about it.
Yeah. So yeah, with the advent of the 3D printers getting better and cheaper, and software getting better, and Tormachs getting better and cheaper, all that garage shop manufacturing is probably going to be a force to be reckoned with in the economy, I believe.
Yeah, I agree. I mean, I think it already is definitely on the machining side of things. You can put an entire machine shop in a two-car garage
Yeah.
and be able to produce almost anything. You may not be able to produce it at a massive scale, but you can produce just about anything.
Right. If you're the
Um,
guy that can hit the price point for the guy that only wants a run of 100,
yeah.
yeah.
We had Kirk Van Filipowski on the
Hmm.
show,
Yeah.
making pens. His machine shop is in a two-car garage. He has two lathes and two milling machines. And the milling machine that he just put in is a Sile, and it is a pro level machine on all, like, that's what the big boys have.
Hmm.
And it is amazing. And he's doing incredible work in terms of tolerance and those sort of things, out of a two-car garage. And I I love it. I think you're going to see a return to American manufacturing at a small scale that's going to be pretty cool.
Yeah,
Open a lot of doors.
specialized small scale.
Yeah. And you know, that's what's missing right now. When you go to any job shop and you say, I need 50 of these parts, they laugh at you and they say, well, we usually start at about 10,000. Come
Right.
back when you have some money. And it's like, it's really a huge barrier to entry to somebody who is an inventor or a product designer that needs a couple prototypes made. Like you just can't, there's almost nowhere to have that done.
Yeah. Well, I mean, China is an affordable
Mhm.
place to prototype. It's affordable to have things even at a small scale made there. And like people are always like, oh, this is that cheap Chinese made shit. And I don't think it's because the Chinese make it cheap because they don't know how to make it is because that's what they were told to make. Like the person that's hiring them told them these are my tolerances. This you need to meet this price point. I think they have enough manufacturing experience in that country to make anything you want at any tolerance level you want, but you have to be at the right price point.
Yep.
You got to be able to be willing to spend for that level of execution.
Yeah. Chinese labor and Chinese materials still cost money. Everybody
Hmm.
thinks, like, oh, they work for pennies over there. That's not true, right? You look at the cities in China. I don't want to get on a political debate or
Right.
any of those kind of fun things, but they're real people with real lives and they, live in houses and drive cars and all the things that we do. It's not a third world country.
Yeah,
And I think
and then
some people,
some. Have you seen their trains that they have there? Like their public transportation is fucking amazing
yeah,
compared
they're,
to
they're
the piece of shit bus that breaks down in our cities.
there is a lot of that. And I do some business with China. I try and do as little as possible because I like to promote companies in the USA. We're a USA made product, and I think I have a lot of pride there. But there are certain things that I cannot get done in this country.
Hmm.
No one will produce them for me at the quantities I need them. And um, part of my limitation is I don't have tons of room for inventory. So if I get 10,000 of any given part, I have nowhere to put it. And so I'm limited. We try and deal with about 1,000 parts at a time maximum for any given thing. And some parts we deal with a dozen at a time. And there's very few machine shops in the United States that will do a dozen parts of anything. Now,
Yeah.
I have a huge advantage because number one, I have machines out in my garage. If I want a dozen of something, I can go make a dozen of something. I also have a machinist that does a ton of work for me uh, that just says, if you need one part, Greg, I'll make one part. And he charges me for it.
Right.
But he can make any quantity that I want. And so we try and we try and figure out the setup time and then what makes sense in terms of part run, right? Like, so you do the setup one time, and then if you run 1,000 parts, you're only paying for one setup. If you run 10 parts, you're still paying for that setup. So I have to make that call from a financial perspective of what makes sense at that point. And if I'm producing a new product and trying to figure out, is that product going to sell? Sometimes I'm willing to take that risk and say, you know what, we're going to set this up and we're going to run half a dozen parts and they're just going to be really expensive parts. And I'm going to sell them at cost and see what happens. And then we know the next time we run them that we're going to run 100 parts instead of 6 parts and we'll be able to make a little bit of money.
Yeah, yeah. That's when that dirty dozen can get you in trouble if the setup cost is really high or the setup time
Yeah.
is really high. That could definitely get you into some trouble. And when I'm making these parts, I did not time myself on these. And a lot of this stuff is made from scrap wood because I knew I had this plan, and so I've just been stacking scrap wood in the
Yep.
basement. So I didn't really have a lot of material costs in it. So I'm going to price these at the first show what I think they will sell at, and then the next time I go to make them on version two, I'm going to be like, all right, can I hit that price point because it sold well at that price point?
Yeah. Yeah. and sometimes there's the as business owners, right? You can decide how much your time is worth. And,
Right.
if you've already put in your quote unquote 40 hours for the week, now you're on free time, and well, I've got all this scrap wood that I can turn into money. So maybe I'll invest, 6 hours of my time into making scrap into something sellable. Well, what did my time really cost? I don't know. Maybe I don't
Yeah.
pay myself anything,
And
but
I stopped worrying so much about prototyping. So thing like the cost of prototyping thing is just like a
yep.
cost of doing business. Like when you put an ad in the phone book, you have to pay that ad. So you have to develop new products, you have to just pay that. And then I don't worry about it. Once I get that product going, some products are going to win, some products aren't going to win. I think you're the one that told me the ATM machines
Yeah.
that have some ATM machines spit out a lot of money, some ATMs not so much.
Some ATMs are unplugged.
Unplugged, yeah. Sometimes you got to scrap the ATM and cut your losses.
I, I
Yeah.
got one of those right here. This ATM never got plugged in. Uh, I I made some really nice, awesome looking throat plates for the Delta Unisaws
Yeah.
that never
Or
hit the market.
well, they're also the quantity are is dwindling away. SawStop is
Yeah.
kind of eating everybody's
Yep.
lunch. But yeah, so one last note on your um storage issue. Like you don't have storage space for 10,000 parts, but like that's part of my problem too, but also like cash flow. There's
Mm.
a guy out the street from me that has a whole bunch of slabs and he keeps trying to sell me these slabs like, oh, I'll make you a deal if you buy the whole tree. Well, if I don't have jobs for that right away, that ties up my cash for a long period of time. And then also I got to store it, which I'm out of room, man. It's either going to hang from the ceiling or make the wife mad that I'm going to stack it in the guest bedroom or under our
I
bed or something.
I I've got two boxes of guitar neck blanks upstairs next to my bathroom because there's nowhere else to put it. And my
Yeah.
wife's like, "How many more boxes of wood are we gonna get?" I'm like,
Yeah.
well, I'm rapidly trying to turn them into guitars, but yes, there will be more boxes, and hopefully at some point we'll have a little more space. But for right now, we're here.
Yeah.
So, well, cool, Brian. I think we've been on here a little over an hour, maybe.
Yeah.
Um, this was great insight, great fun conversation for sure. I think for me, it's always I say things a lot, but then you have to remind yourself that those things are still true, and failing does not mean that you failed. Failing means that you're getting closer to the right answer, and I think that's a really important thing for everybody to remember.
Yeah. Absolutely. I got nothing else to add. Do you want to take us out?
I will. Cool. Well, I am Greg Porter. You can find me at Greg's Garage KC on Instagram and YouTube. You can also find me at Skyscraper Guitars.
And I'm Brian Benham, and you can find me at Benham Design on pretty much every platform out there. And you're listening to the Maker's Quest podcast. If you want to check out any of our back episodes, go to themakersquest.com. We have them all published there. Thanks for listening.